Welcome into this new devlog of OpenVoxel. In today's video, we're going to talk about the logging system. I was planning to talk about the profiling system, but I'd rather try to talk about the logging system almost line by line so you can have a very good understanding of the logging system. You might be able to use it after this video and just maybe it will give you some ideas for your own logging system if you do so. So the logging system is one of the most important pieces of a game engine. There is no game engine that don't have a logging system, and that's because it's very useful to display information of what's happening which can't be displayed on the screen. And to do that, I could have been using a library. I'm pretty sure there's plenty of them, but instead I'm gonna use my own because I really want to have the hands on what's happening, and also because I don't want too many fancy features that sometimes logging library may provide. So instead I'll be making my own very basic implementation, and then in the future we'll be able to improve this system. So for now what we can do is log message onto the console. We'll have some different categories to know where the message comes from. Is it from Vulkan? Is it from the physics engine? Is it from something else? We'll also have the ability to disable the logging system and remove every cost of performance that the logging system may take, because logging is actually pretty slow. So being able to remove the whole thing at compile time can be very handy. And we also have different type of verbosity to know the severity of the message, if you like, such as error, warning, information, and a bunch more. So let's get right into it. So if you go into the core module into runtime, there is a logging folder which contains 3 files. Logger.h, which contains the class that will log the message onto the console, and the files when we'll be able to log onto files. We're not able to do that now, but it will be implemented in this class. The logging macro.h, which is the file that you're gonna use to use the logging system pretty much. So if you want to do some logging, you have to include this file. And the last file is the logging type.h, which contains all the types for the logging system. So in this file, there is two things interesting: the namespace verbosity and the class log category. The verbosity namespace contains all the things about the verbosity, such as all the verbosity options, like fatal, which is a verbosity that will crash the application after logging the message. It's very important when you're doing something that is absolutely required for the engine to run, like Vulkan, for instance. You can log the message like no GPU and crash the application right after. And in the future, we can be able to catch this fatal verbosity and create a new window that will ask for reporting the error or something like that. You got error, which is an error message, warning, which is an error message, but less severe, I guess. And you have verbose, which is the information verbosity. So every information that you want to show on the console, you'll have to use verbose. And you have display and very verbose, which are adding another layer onto the logging system. And that's the difference between logging onto files and logging onto console. You most likely want to log onto both the files and the console, but sometimes you just want to log onto the console if it's a debug message, for example. So you can be using display for that, or if it's an information that is important for debugging but not required onto the console, you can log only on the files using very verbose. A nice thing to notice here is that verbosity is the name of the namespace and not the name of the enum. And that's because, if you didn't know, you can, we'll just create a dummy variable. You can access the verbosity option using just the namespace name. So if I'm doing something like that, where tt is equal to verbosity display, which display is this verbosity option inside the enum type, it's still valid. And that's really great, because what you can do now is also adding function, which is kind of they were like into the enum. And just below the verbosity namespace, you also have the log category. So the log category is the class that will be created when you create a new log category. For now, it's just holding a name which can be accessed from the logger using the accessor getName, but in the future we'll be adding probably more stuff in this class. And talking about the logger, we can go into logger.h, which contains the static class logger, which is the class that will print the message onto the console and write onto the files when we're having the file system, of course. So there is two functions, log and log onto console. Log onto console is just a function that we call stdcout and log the message, the end message onto the console. And log is the function that will create the end message and log onto the files or the console and crash the application if needed. So as you can see here, I got my if verbosity is equal to fatal, then you crash the application using assert. At this line, that's where I'm creating the end message. Using std format, I'm printing the name of the category onto brackets, then the verbosity level, and then the message, which is already a message that has been formatted if you want to include variable onto your message. But we'll see that in a few seconds. If I'm going on to logging macro.h, that's where everything comes together. So as you can see, like I was talking previously, I also have an std format here, which take a format and some variadic arguments to be able to include a variable inside the message that you want to log. So the ovlog macro is the most important macro here. That's the macro that calls the log function inside the logger with the verbosity, the category, and the message formatted. And it's also doing some static checks just to make sure that the log verbosity is a verbosity and the category is a log category. Okay, you also have some helpers here with ovlog array and ovlog if, which ovlog array is printing an array. It's iterate through all the entry of the array and calling the ovlog macro on it. So that's pretty handy because you can print a whole array using a single line. Otherwise, you need to do something like this, where you have to wrap the for loop inside the no logging statement. Sorry, it's a not no logging or with logging, because that makes more sense to have a define. That's what this define exists, because otherwise you have to call no not logging, which is harder to understand. So you can do a with login. So if with login, then you loop through the array and you log the message. I do that because the with logging and no logging are the thing that remove the logging system, and by doing so, it will just remove the macro, and you'll still have a for loop that will loop through nothing and taking performance, even though there is nothing onto the console because there is no logging system. So we'll take a look at that in a few seconds. So that's why the ovlog array is for quickly log into arrays and be able to replace the whole thing when there is no logging system. The ovlog if, it's the same thing, but instead of an array, you're having to pass a condition, and if the condition is true, then the log will be displayed. And the second most important thing is the declare and define log category macro, those two here. Those are very important because it's able to create new categories for the logging system. And if you ever use Unreal Engine, it may sound familiar to you because it's using the same pattern that they use. I found it very useful when I was coding with Unreal Engine, so I implement the same thing pretty much. The way it's works is that you have to declare the log category onto your header file and you define the log category onto the CPP file. You do that because if you define onto the CPP file, into the header file, sorry, you'll have some duplicate because it's a global variable. So instead you declare it, telling that, oh, this variable exists, it's this type, and it's somewhere into the source code. And then you define it onto the CPP file to implement the log category that you tell that was existing. So it's kind of like a forwarding structure or classes. So let's take a look at that to start with. So everything I've talked so far. If I go into Vulkan implementation.cpp, .h, you can see that in line 8, I'm declaring a log category called log Vulkan, which I'm defining here at this line, define log category log Vulkan. Then in my code, I'm able to log using verbosity, which is here very verbose, the category log Vulkan, and my messages. I can also log arrays very easily using the same thing, log very verbose, log Vulkan, the array, and my formats. Into vulkan swapchain.cpp, I'm pretty sure I got a log if. Yeah, here I got a log if, which is logging if the vulkan result is not success, then I'm logging as usual. So log if the condition, which is the vulkan render result different than success, then I'm printing a warning with the log vulkan logging category, and I'm writing my message. I can show you that now. So as you can see, okay, I got some error, but if you avoid the error, as you can see, I got my log vulkan, which is the category, verbose, which is the verbosity option, and the message that I want to display. And for the array is those logs here, which are the extension, I think, or maybe it's the, yeah, it's the extension, the layer is this one. Anyway, that doesn't matter, but as you can see, it's logging perfectly. And if I'm going back into logging macro.h, and this time I'm defining no logging. Now, if I do it again, as you can see, the whole logging system is gone. And that's because when you're defining a macro, let's say a TT, which is equal to 1, when every time you call the TT macro, your compiler will replace TT by a 1. So if I'm saying that when no logging is defined, which is the case here, the define is empty, which will remove the whole thing. But if no logging is not defined, this time the other one will, the color will switch, and TT will be replaced by 1. 1, like so. So that's what I'm doing here. I got all those macro once again here, but with empty macro implementation. Those are just placeholders. You can see it's a macro with nothing. It's just to be explicit that this is an empty macro. So that's what's happening with the no logging define, and how do I remove the whole logging system at compile time. So hopefully all of this makes sense to you. You can go in the description, there is the source code if you want to check by yourself and just look exactly where all those things goes. Yeah, and if you have any question, I'll see you down in the comments. Otherwise, I'll see you next week for another devlog. Thanks for watching.